Hello, welcome to the Data Structure and Algorithms online tutorial video. In the previous video, we learnt about the arrays. In this video, we will learn about the linked list in detail. Let us have a quick look on overview of the things you are going to learn in this video. What is linked list? Declaring linked list. Why do we need linked list? What is a node? Types of linked lists. Singly linked list, doubly linked list, circular linked list, doubly circular linked list, singly versus doubly linked list. Advantages, disadvantages, applications, code to implement the linked list. First, we will understand what are linked lists. Linked lists are containers where data is stored in nodes. The nodes consist single data item and pointer or reference to the next node. A linked list is also a collection of elements, but the elements are not stored in a consecutive location. The elements are linked to each other by providing the address of the next element with an element. The variable that stores the address of the next element is known as pointer. The linked list contains two parts. First one is the data element and the other is the pointer. The pointer variable will occupy 4 bytes, which are pointing to the next element. Here is the example of linked list. We can observe that each node contains the data and the address of the next node. The last node of the linked list contains the null value in the address part. Declaring linked list. We can declare the linked list by using the user-defined data type known as the structure. The structure of a linked list can be defined as, we have defined a structure named as node consisting of two variables, an integer variable data and the other one is the pointer next, which contains the address of the next node. Why do we need linked list? In arrays, we fix the size at the compile time, due to which wastage of memory occurs. The solution to this problem is to use linked list. What is a node? The node is nothing but a link in the linked list. The node contains two things. It contains a value and it contains reference to the next list. Types of linked lists are singly linked list, doubly linked list, circular linked list, doubly circular linked list. Now we will see these in detail one by one. The singly linked list is a data structure that contains two parts. One is the data part and the other one is the address part, which contains the address of the next or the successor node. The address part is a node is also known as pointer. In the figure, there are three different nodes having addresses 10, 20 and 30 respectively. The first node contains the address of the next node 20. The second node contains the address of the last node, that is 30, and the third node contains the null value in its address part as it does not point to any node. It contains only a single link in this list. Only forward traversal is possible. We cannot traverse in the backward direction as it has only one link in the list. This is the representation of the node in the singly linked list. Struct node, int data, struct node, asterisk next. Doubly linked list is a linked list that provides the forward iteration from the start to the end of the list and reverse the iteration from the end to start. Traversing from the current node to the next and the previous node is possible. As we can observe in the figure, the node is doubly linked list has two address paths. One part stores the address of the next, while the other part of the node stores the previous node's address. The initial node is doubly linked list. It has the null value in the address part, which provides the address of the previous node. Representation of doubly linked list. Struct node int data, struct node asterisk next, struct node asterisk previous. Circular linked list. The difference between the singly linked list and circular linked list is that the last node does not point to any node in a singly linked list. So it is the link part contains a null value. The circular linked list is a list in which the last node connects to the first node. So the link part of the last node holds the first node's address. Circular linked list is a variation of a singly linked list. The circular linked list has no starting and the ending node. We can traverse in any direction, backward or forward. The linked list is shown here. A circular linked list is a sequence of elements in which each node has a link out to the next node and the last node has the link to the first node. The doubly circular linked list has the features of both the circular linked list and doubly linked list. The last node is attached to the first and thus creates a circle. Each node holds the address of the previous node also. The main difference between the doubly linked list and the doubly circular linked list is that doubly circular linked list does not contain the null value in the previous field of the node, as the doubly circular linked list contains three parts, that is two address parts and one is the data part. So its representation is similar to the doubly linked list. Now let us see the difference between the singly versus doubly linked list. The singly linked list requires the lesser memory compared to the doubly. Singly linked list can't be iterated in the reverse, while doubly linked can be. Deleting the previous node in the doubly linked list doesn't require any traversing. Advantages: dynamic data structure. The size of the linked list is not fixed as it can vary according to our requirements. Insertion and deletion in the linked list are easier than arrays. As the elements in an array are stored in a consecutive location, the elements are stored in a random location in the linked list. The complexity for the insertion and deletion of the elements from the beginning is big O of 1 in the linked list, while in the case of an array, the complexity would be big O of n. Memory efficient. The size of the linked list can grow or shrink according to our requirements. Implementation. Stacks and queues are implemented using a linked list. Disadvantages. The node in a linked list occupies more memory than array, as each node occupies a simple variable and another is a pointer variable that occupies 4 bytes in the memory. The traversal is not easy in the linked list. If we want to access the element in a linked list, we cannot access the element randomly. Backtracking or reverse traversing is difficult in a linked list. In a doubly linked list, it is easier, but it requires more memory to store the back pointer. Applications of linked lists are: the polynomials can be represented using a linked list, and also we can perform the operation on the polynomial. The linked list is used to represent the sparse matrix. The operations like student details, employee details, or product details can be implemented using the linked list, as the linked list uses the structured data type that can hold different data types. Stack, queue, tree, and various other data structures can be implemented using a linked list. To represent the graph as an adjacency list, a linked list is implemented. To implement hashing, we require the hash tables. The hash table contains entries that are implemented using a linked list. A linked list can be used to implement dynamic memory allocation. For detailed notes, you can install the DSA application from Google Play Store or from the link given in the description below. Please like the video and subscribe to our channel and hit on bell icon to get notified whenever we post new videos. Thank you for watching, and let us know if you have any queries in the comment section below.